Good morning, students. Welcome to online class of mathematics of the first year B.sc first semester. This is Nagar Miravali. Okay, now we are going to discuss about the first unit, partial differentiation. Okay, in this one we are going to talk about the partial differentiation, which is the first unit. In this part we have to discuss about the function of two variables, neighborhood of a point, and continuity of a function at a point. Already we know that the definitions about the functions of one variable, so a neighborhood of a real number and continuity of a function at a point. Here these all definitions can be talking about the two variable functions. Okay, now also partial differentiation. We know that already differentiation is the process of finding the derivative of a function with respect to a variable. Here we are going to differentiate the partially of the two variables with partially with a variable for the two variable function. Okay, let's start. Okay, let me discuss about the function of two variables. Function of two variables. So let me give the example for the function of two variables. Let us consider the polynomial x square minus 2xy plus y square. So observe that in this polynomial you have seen here x and y variables here. So that means if you find the value of this polynomial, you need to give the output x is equal to something and y is equal to something. So you will get a value. Suppose if you take an x equal to 1, so you will get this one is 1 minus 2 into x into y means 2 into 2 4 plus y is equal to 2 means y square means 4. You will get the answer 1. Okay. So to find the value of this polynomial, you need to take the two values x and y. So that's why we can take this one x square minus 2xy plus y square as an example for the function of two variables. Okay, this is about the example for the function of two variables. Okay, now let me give an example for the function of two variables. So one more example. X square minus 4xy plus y square minus x plus y. Okay, this is also to find the value of this polynomial. You need to take the value of x and value of y. You will get a y output. Okay, to find the output of this value, you need to take two values x and y. So that's why this is said to be the function of two variables. Okay, so next one. Let me write the definition of function of two variables here. Okay, students, this is the definition of a real valued function f of two variables. A real valued function f of two variables is defined. It can be defined to every number x comma y. If you take in, for example, x square minus 4xy plus y square. Okay, if you want to find this one, you need to take x value and y value. These values can be taken in order pair. Suppose x is equal to 1 comma 2. So like that, how many values you can give for to find this function. Okay, these kind of points can be taken in the set of D. In the set name is D. So that means this set D contains the ordered pairs. Ordered pair means like that. Okay, 1 comma 2. If you take in 1 comma 2 like that, it is said to be the ordered pair. Okay, of real numbers there is associated a number. If you take in 1 comma 2 as an ordered pair, there will associate a number to this function. If you take in another number 2 comma 0 for x as 2, y as 0, in this one you will get another number associated with this number. Okay, so this is said to be the definition of the two variable functions. Okay, Now what you have taken the set of all ordered pairs, okay, what you have taken the set of all ordered pairs x comma y to find the value of the given function. That set is called the domain of the function. Okay, this is the definition of the function of two variables. Okay students, now we are going to give the examples for the two variable functions. Examples: let z is equal to e power minus x square minus y square. So to find the z value, you have to take the x value and y value. So that means the z is depending upon the x value and y value. So this is the example for the two variable functions. Next one, the function f can be defined as square root of x square plus y square minus 1. So if you find the x value and y value, if you find the f value, you need to take the values of x and y. Okay, and also we know that x square minus plus y square minus 1, this will be in the square root value. So if a number is lie on the square root value, this is always non-negative value. So that means now I am going to write x square plus y square minus is greater than or equal to 1. Okay, this is the condition here. So in this one, if you take an x square plus y square is equal to 1, it will be of the form x square plus y square is equal to r square. So have you any guessing here? Here this is the circle represents this is the equation of the circle in standard form, having the center 0, 0 and the radius r. Here r value is 1. So now if you find circle here like that, the diagram of this one, so center is 0, 0 and you have taken any point at distance 1 unit distance. Okay, so that is the domain of this second function is the circle within the radius 1. Okay students, so that is the explanation about the real value function of the two variables. Okay, next, so they have the example for the function of two variables. Next one, I am going to talk about the neighborhood. Neighborhood of a real number. Already we know that these definitions in the intermediate level. So let me discuss about the neighborhood of a real number. So we are going to find the neighborhood of the real number. First you need to take a real line here. Suppose I am going to take the real line here. So we know that the real line means you're starting with minus infinite to plus infinite. Here also middle value 0 is there. Right of the 0 is the positive part and left of the 0 is the negative part. So neighborhood of a real number means, let us take the first of all a number. Let some x is a real number. So that means I have to take a real number x here. So neighborhood of the real number x means, first you need to take the neighbors of this value. Neighbors of the number x is the one neighbor is lies left hand side and another one is lies on the right hand side. Here if you take in on the right hand side, there will be so many neighbors are there. So these neighbors are depending upon the distances you have taken. Okay, if you taken the neighborhood at 1 unit distance, a neighbor is x plus 1 distance. If you taken 2 unit distance, this is the x plus 2 distance. In the same way, if you take in the left hand side direction, this is x minus 1 distance, x minus 2 distance. So they all are the neighbors of the number x. Okay, so here if you take in the neighbors of the x means they are depending upon some distance. So suppose I have to take a distance if delta is greater than 0 at the right side of the value of x here at the distance delta. Now it's a neighbor on the right hand side, x plus delta. If you take in the left hand side, you will get here x minus delta. Now the set of all points which are lies between x minus delta and x plus delta. Okay, so the set of all points is called the this part is called the neighborhood of the real number x. This is the neighborhood of the real number x. Okay, so let me write the definition of neighborhood of real number. If delta greater than 0, then x minus delta and x plus delta open interval is called the delta neighborhood of x. Delta neighborhood of x. So for example, if you take in a number 1 and with the length delta as 0.1 unit distance, the neighborhood of 1 is left right to the 1 is 1.1 and a left point of the 1 is 0.9. So this interval is called the neighborhood of 1 at the distance 0.1. Another one is if you take in the distance 0.2, the neighborhood of 1 is 0.8 to 1.2. So this is the 0.1 neighborhood of the number 1. This is called the 0.2 neighborhood of the number 1. Okay, like that there are so many neighborhoods are there for a real number. Okay, we have to write the note point here. Note point, we have to write there are infinitely many neighborhoods for a real number. So they are the note point for the neighborhood of the real number. Okay, next one is, now I am going to discuss about the neighborhood of a point. We know that the points are denoted by the order pairs. So the order pair can be plotted in the coordinate plane. So that means I have taken a coordinate plane. Let us take, this is x-axis, second one, this is the y-axis, okay, this is y-axis, y dash, this is the origin, we know that origin. So neighborhood of a point means we know that the point can be represented by the order pair. Let me take the point here. Let x comma y be a point. Suppose if you take any a point here, x comma y, this is the point here you have taken. So whenever you have to take a point, now the foot of the perpendicular of that point to on the x-axis is at a distance from origin to this one is x. In the same process, the distance from origin to on the y-axis foot of the perpendicular of x comma y is, suppose I have taken y. So if you want to take a neighborhood of a point x comma y, already we had discussed about the neighborhood of a real number. So here we have taken x-axis and y-axis, both are the real axis. Okay, they represent the real line. So x-axis is also a real axis, real line, and y-axis is also a real line. To find the neighborhood of a point, we need to take a distance. Okay, if delta greater than 0 is the distance. So this distance can be taken on the x-axis from the point x here, from the number x here. We have to write here x plus delta. On the left hand side at the same distance, x minus delta. X minus delta, this one. Okay, the same process. If you taken at the same distance on the y-axis, you have to write here, this is the y plus delta. If you taken on the upward direction delta unit distance, that point is y plus delta, and downward direction delta, this is y minus delta. Now if you join these all points, we can write the foot of the perpendicular at x minus delta, sorry, not a foot of the perpendicular lines to x minus delta and x plus delta, or to the x-axis, and perpendicular lines on the y-axis at x plus delta and y minus delta and y plus delta. You will get here this one, the same process. Okay, the region which is lies in this square. This is called the neighborhood of a point x comma y. Okay, student. So if you observe that the neighborhood of a point x comma y is the square with the side delta unit. Okay, this is the neighborhood of the point in the coordinate plane. Okay, if delta greater, now we are going to write the definition. If delta greater than 0, then the set of all points which are in a comma b such that a lies between x minus delta, that means x coordinate lies between x minus delta and x plus delta, is less than or less than a is less than x plus delta comma, and the y coordinate b lies between y minus delta is less than b is less than y plus delta. Okay, then the set of all point a comma b such that this one is called the neighborhood of a point x comma y. So this neighborhood length is delta. Okay, so the neighborhood of a point x comma y at the distance delta is a square of side delta, so they all are the delta distance. Okay, this is the neighborhood. The shaded region in the yellow color is the neighborhood of a point. Okay, now let me start about the continuity. Next definition is, what is that? Continuity. Continuity of a function. Already we know that continuity of a function in one variable. So let me remember that the continuity of a function in one variable. Suppose f of x is a function in one variable and its domain is, suppose I have taken a to b here. Now the domain of the function f is a. So first of all you need to take a point in the domain. Let this is the point in the domain. So the function f is said to be the continuity at the point A. That means all the domain points will goes to near to A. Then their images means x image f of x. Their images will goes to f of A. Okay, that means as x tends to A, then f of x tends to f of A. This can be mathematically written as limit of the function f at A is equal to f of A. Okay, this is the simple mathematical notation of the continuity of a function f. Okay, now we are in the continuity of a function in two variables. That means first we need to take a function in two variables here. After taking the function in two variables x comma y, we need to take the domain point, that is a comma b. Okay, this is the point in the domain. That means all the domain points x comma y approaches to a comma b, then its image f of xy will approaches to f of ab. This is the definition of the continuity. So this can be written as limit xy tends to ab for the f of xy is equal to f of ab. This is the continuity of a function in two variables. Okay, now I am going to write the definition of the continuity of a function. Students, so let me write. Okay, let f of xy be a function in two variables. General definition is a limit xy tends to ab, f of xy is equal to f of ab. This is the definition. So this can be written as simply as xy tends to ab, its image f of xy tends to f of ab already we had written. So two variables, and f is said to be continuous at a point a comma b. So where a comma b, at a comma b in the domain D. So we have taken a domain D. If here for each epsilon greater than 0, epsilon means this is the distance, epsilon greater than 0, there exists a positive number delta greater than 0 such that f of xy minus f of ab, modulus of f of xy minus f of ab is less than or equal to epsilon for a minus delta is less than, x is less than a plus delta, and b minus delta is less than, y is less than b plus delta. Okay, this is the definition, and it is simply denoted by limit xy tends to ab, f of xy is equal to f of ab. This is the definition of the continuity of a function. Okay, students, note this definition. Next one. This is the definition of continuity of a function in two variables. Next, I am going to write the partial differentiation. Partial we noted the differentiation in the lower section. A differentiation is the procedure to find the derivative of a function. So for example, if you taken a function in one variable f of x, it is said to be the differentiable at a point a. Now the definition is limit x tends to a f of x minus f of a by x minus a exists. Okay, if this limit will exist, then we say that the function f is differentiable at the point a. So the general formula is a function f is differentiable function at not particularly one point, at everywhere. Now we have to use the definition limit h tends to 0 f of x plus h minus f of x by h exists. Okay, this is the definition of the function in one variable. Now I am going to take here differentiability of the function in two variables. Two variables means here we have to take either of the variables x comma y, either x or y here. Okay, so that means if you want to differentiating with respect to x, then we say that the function is differentiable with respect to x partially. While we have differentiating with respect to x, here y can be treated as the constant. Now I am going to write the definition here. Let us take, suppose this can be moving downward. Now let f of xy be a function in two variables. Then limit h tends to 0 f of a plus h comma b minus f of ab by h exists. Then you have to write here if, then f is said to be the partial derivative of f with respect to x. Here observe that in this formula here a plus h and a is there, here b is the constant, so that means y coordinate will be constant. Here the x coordinate have changed to a plus h, so that's why we say that the partial derivative of f with respect to x at the point a comma b, okay, and it is denoted by dou f by dou x, that means derivative of x. Generally derivative of x means d by dx, you can write d by dx. Here we are in the partial differentiation notations are dou by dou x, like that we have to write here. Okay, now so here we had differentiated here at a particular point, that is, what is that point? A comma b, that means we have to write the point a comma b. Okay, and similarly we can write the partial derivative with respect to y. So that is like that. If limit h tends to 0, f of a comma b plus h2 minus f of a b by h exists, then f is said to be the partial differentiation of f with respect to y at the point a comma b, and it is denoted by dou f by dou x, dou y by dou y at the point a comma b. Okay, so they are the general definitions at a particular stage, that means particular point. Now in generally a function f is differentiable partially with respect to x. Okay, that is note point I am going to write. If limit h tends to 0, f of x plus h comma y minus f of x comma y by h exists, then f is differentiable with respect to x partially. Differentiable with respect to x partially. Okay, simply it is denoted by dou f by dou x. It is denoted by dou f by dou x. Dou f by dou x, or simply f at x. Okay, f at x. The same process, now differentiable with respect to y. So here you need to change here this step like that. F of x comma y plus h minus f of xy. Then f is differentiable with respect to y partially, and it is denoted by dou f by dou y. Dou y and f at y. Okay, so they are the definitions of partial differentiation, students. Now in the next class we are going to discuss about how to differentiate partially a function with respect to x and with respect to y with some examples. Okay students, I hope you understand this problem, this concept. You have to note the definitions, all definitions in your notebook. Okay.